Um, seems, seems we have a full comment here and hello, Manson. I see. Let's start from me. And last week I managed to I was working on the MakeFS support, and turns out it involves much more than MakeFS support of Chrome OSD. I'm pushing the working progress branch to the GitHub. Probably you can take a look at it. Branch name is hold on, I'm posting the URL in chat. Here it is, and currently it includes the support of preliminary MakeFS. I'm still testing it, and another change is to copy pretty all of the functionality of a memory store and object store from the source dash slash OS to Chromis OS by removing all the blocks and the blocking and other facilities not supported by Seastar. Ideally, it should be a drop-in replacement of a memory store, and can use it as it is in Chromis OSD. Based on which, I'm adding the support of read and write support of a mem store. So I can read a persistent object OSD map and load it later on when the OSD is done. It should be binary compatible with the memory store, the dump format of memory store. It will help us to debug the OSD later on. And the missing piece is, I think, the LRU cache. But I think probably the right way to work on the LRU cache is to have our own forks, because as Rico pointed out, there's a lot of space we can improve in Seastar syntax implementation, and the requirement of a object context and that of OSD map is quite different. The former does not require the ordered map, and the latter can need the ordered map because it needs the lower bound support to get the smallest OSD map given an epoch. I will post the trimmed down implementation of LRU cache. It is based on Jenpeng's work and Riddle's change. I think that's me. And how about you, Chen-Mei?
So the parent branch you are working on, what's the difference with the PR you merged in?
I think the major difference is the full copy of a memory store without blocking I/O and MKFS and a preliminary of a PG backend.
So you modify the file copy in the memory store.
File copy. I'm not. Could you be more specific regarding file copy? Is it a function name or?
No, I just want to know what you modified in the memory store for the
Okay, cool.
file code.
I basically removed all the locks and only copied the necessary pieces from the memory store.
Okay, I see.
So we can add more, like we can copy more stuff and customize it whenever we need more functionality when we implement Crimson OSD without bothering the provocation function semantic we have in the existing memory store.
Okay.
Before that, I thought we need to reuse the memory store as much as possible, but since we are trying to get the fast pass as soon as possible, we just need to fork it and later on we can have a wrapper like featureized memory store or featureized object store as suggested by Redoc, and just plug it into the science store. By the way, I named it the science store, which has a featureized interface. But underneath it, we can replace it with the wrapper you are working on.
So last week, after I reviewed your PR, I think for the OSD initialization function, so I think we can start up the reactor later, just for the working thread. So the initialization work can be done before the reactor startup. So then we needn't to modify the code. All the code can be called as the existing OSD that is running as the currently, and then we just pass the object or the instance we needed to the Seastar thread. That the Seastar thread working as working as the working thread, getting the network I/O and handle the I/O, all that logic running in the reactor, the Seastar thread. But before the reactor start up, the initialization work can be done as normal.
I see. But what's the upside of this approach? What can it buy for us?
What can buy? Sorry, I don't understand your question.
Sorry. My question was, what's the upside of this approach by moving the initialization code out from a reactor?
You needed
from this approach.
So the initialization is the code is there. It's already verified, and the initialization is we needn't consider the performance or something because it's just called once, executed once, and we needn't care about the log, the block, and the other things. We just prepare the for example, the variable, the instance, the object, something like that. Then we just transfer that to the initialized object to the working thread. The working thread only need to consider the.
Did you get a chance to read the what we have in Chrome OSD? What exactly we are missing, and it is provided by existing OSD, so we can benefit from the existing code in existing OSD without reactor support.
I didn't compare the code. So I think in our currently OSD drivers, so only I think you initialize some configure, right? Messenger. monitor client.
The point is what we are missing.
I don't know. I
That we
didn't
can
compare
leverage from the existing OSD.
Yeah, I didn't compare the code. I just have that idea, but I didn't know what we are missing.
Yeah, we need to figure out what we're missing, and so we can leverage your change, your proposed change.
Yeah, so maybe something can be initialized before the reactor startup. It is easy, just literally OSD code do.
Yes,
And
so
we
you
only
need
consider
you might want to be more specific regarding to the existing code, what we can leverage from it, and what we can benefit from it.
Okay.
Yeah.
So what did I say? So the current POC only consider one thread. So for the configure and OS map, we didn't sync the multiple thread, just like what the OSD do now is okay.
No, we don't.
But it's just one thread.
Right.
So we needn't change the code now.
Yeah, I think I proposed the testing methodology in the mail I sent to Steve Devil. Probably if we can clarify it if it is confusing. Where I suggested we are going to be using multiple instances of Crimson OSD.
Multiple instances? You mean multiple thread?
Multiple process. Each one will be hosting a single OSD.
Okay, so you're still considering the multiple thread, right?
No, multiple process. Each process will be hosting a single thread.
Multiple. Sorry, can you repeat?
We'll have for example, if we have we'll have a apple-to-apple comparison, right? If we have 8 cores, we will start 8 process.
Yes.
Like we have now. What we have now in multiple process OSD deployment model. But in
so you want the multiple thread, multiple process share the same OS map?
No. Each of them will have its own OSD map cache.
So multiple process share one OSD map.
Each process will have its own OSD map cache.
Okay, I see. So that
it
is
will
my
not
question.
Be shared.
So that's my thinking, right? We needn't consider how to modify the OSD map. So currently OSD map works for the one thread.
Yes, I think so.
We needn't modify the OS map. We needn't modify the configure. We needn't modify the CTX because we only have one thread. We can use the current code. All the data structure, we can use the current code.
Could you be more specific? What do you mean by all data structure?
Because just one thread, we needn't consider how to share them.
I think we still need to work on the I/O path, right? For example, we need to read OSD map and write OSD map.
Yeah, but we need to consider how to share it.
But that does not imply that we can reuse all the existing code.
Yeah, we can reuse all the code. We just remove the read block. It's okay.
Okay.
We use the current initialized code. We use the current data structure shared. not shared, just one data structure copy. And we only run the I/O path from the networking to the OSD process and in the reactor.
So you are suggesting that we just don't need to rewrite the code with Seastar and just reuse the existing code base and start
So
benchmarking it?
we only replace the messenger and I/O path logic.
I think that's exactly what we are doing now.
Yeah, but you still mentioned how to merge the Genpeng's OSD map. I don't think it's needed now. And also the configure file.
Because it involves some unnecessary lock, I believe.
The lock we are defined a dump lock under the Seastar currently. It's dump. It's not the real lock.
I think Genpeng's work is to replace some of the, for example, the condition variable with some dummy implementation.
Yes, if it is just for the dummy lock, we can merge in.
So we still needed it, right?
Yeah, only for the dummy lock parts.
Probably we can discuss it later on in more details. But I still believe there's some room to improve. Probably it's not very critical, but since we already have it, why not to get it in the Kubernetes OSD?
Yeah, you can. Just for the dummy lock, it's okay, right? Less code we modified, less debug work.
Yes.
Yeah, so that's my opinion that we just modify the as less as necessary code.
I'm not sure that's the right approach. The idea is to get the work done ASAP instead of have a minimal code change of existing code.
But we just want to compare the performance. This is our target, the first target.
Yes. The point is not to have minimal change to existing code, but to have the implementation, the fast path, rolling out as soon as possible. If it has less, if it involves more, it makes it more complicated. It's probably better to just fork it. That's why I'm copying all the memory store and the object store into Crimson OSD instead of hack on it.
Okay, I agree. So we keep the logic, the same logic, but we want to the code work effective, right?
True. Even we need to fork it.
Yeah, but I think it's only focused on the working thread because the initialization not affect the effective, the performance, not affect the performance. So
I think it's all related to how the performance of a developer instead of performance of Crimson OSD. If we already have it, we can just use it. If you could point out which piece we are missing, probably we need to try to use or leverage existing code. Otherwise, we can have let it be.
Okay. So that's the first topic I want to. And the last week I go through the RAID path, and so how can I show the screen? How to share this? Can you see my screen? Desktop. Can you see my screen?
Not now.
Okay. Can you see my screen?
Yes, I can now.
Yeah. So I go through the main OSD primary OSD I/O process, not the replicator OSD. And so for our test, the first test case, I think we can set the process to be 1, right? You want to do the replicator 3 copy?
I think the first step is to get a read path.
The read path is only 1 OSD, so we can set the process to be 1. And so this is the working flow of the OSD from the messenger. And here I didn't consider messenger. I just consider the OSD.
I really think we need to have a minimal implementation instead of reusing what we have in the critical path. In this implementation, I'm seeing NQ and DQ steps doesn't impact in performance.
Yeah, here I just list the original the existing code now. So here we should remove the enqueue and remove the DQ logic here. We should remove it. I just list the current code path, and here I list some code we need to remove. There is the so there is from the original code in the existing code, there is a sync messenger thread switch to the OSD thread. There's thread switch, and then there is enqueue DQ operation. For read, there is enqueue DQ, and for the read operation will go through this function call, and I think we should remove the enqueue DQ because it's not necessary for our Seastar code. But for there are many condition check in the existing code.
Right.
We should keep that check, but we need to implement that branch.
If any of them are blocking and are sitting in the critical path that in normal cases?
I think there is no blocking because it's read. There are some I don't know, find object context, maybe need to read the cache, the memory there's memory store map, maybe find object context. Yep. They will find where is the object located. But I think it's memory store read, because the memory store when the memory store initialize, they will load the what they call the collections into the memory.
Collection.
Yeah, right. Yeah. So maybe there's no read block here. There is enqueue, DQ, one enqueue, one DQ operation, and check many conditions. But I think we should go the check logic, and but not because the code not go in that branch. We just leave the check condition check there will be okay. And there are many cases to the messenger tap to check the messenger tap. So we can only consider the read case will be okay. And we should need to implement the pull create and RBD image create RBD map image such that command. And
I'm not sure how the RBD relates to our chain, our goal.
I'm not sure. If the OSD need to do something for this command, but for our performance test, we need to implement this command.
I believe we just need to support something like reduce put and reduce get instead of implementing all the semantic required by the librrbd.
Exactly. librd would require even some OMAP, maybe not on the hot path, but for the initialization of processing. I guess we
That will
want.
be more involving.
Sorry?
Pardon, Kefu? What's your
I'm concurring
what did you think?
Redux. I think we just need to focus on the minimal set of librados instead of a requirement of a librd, which is more involving.
So
Yep, sounds that the librados based benchmarking is much simpler.
librettos.
There is a question. Before read, we must write object. So we must implement the right path.
Yes.
Yes,
Simple.
we
That
have
is
to.
exactly why I'm trying to be binary compatible. By binary, I mean the on-disk format of a collection and the object be compatible with memory. So the first step, we can read the dump loaded from the dump of memory store, and later on we can implement the right support of a collection and object supported by memory store.
From this point, using libraries or librd, I think is the same work. Before we must implement the right path.
But I'm not sure the functionality wise, if librd requires more features than libredos requires. For example, it might want to support the OMAP. Do we really want to support OMAP in our test?
Okay, I mean, I know what you mean. You mean for the simple, we only use the OSD OP read or write. But if using libraries, we may use other commands. Okay, I see.
Yes. Yes.
Okay, so for my understanding, we need to implement some commands, and then we can do the FL test, right? And we have implement configure. How do we deal with the CTS?
Context is
Keep it or we remove it?
I'm not sure what is involved regarding to the async calls. What is dependency? We don't have yet, or it's difficult to implement it.
So currently we can just use it because we needed to share it, right? So the logic many configure is read from the CTX data structure.
By CTX, what do you mean by CTX? Is this the safe context or the object context?
The safe context here.
Personally, I don't really want to use safe context.
Okay, so we can modify it. So when the code reads the safe context, we can use our own the new configure.
The minimal implementation of a safe context, which is very have nothing in it.
Okay, I see. So yes, so from this existing code, many condition check. So I think we should keep it and follow the logic as the existing code, but we needn't because the code not go in that condition, so we can ignore the condition implementation.
But my concern is that what the normal cases is. What are the general cases of read operation? Will they be blocked by any of them?
No. I think
No.
no.
Okay, cool.
Yeah,
But
just
is
for
find
read.
object context a blocking operation in for the for
Uh,
for memory store?
I
It
think it's read,
will be read from memory
no
directly.
block.
Yes, I
Yeah, for
agree.
memory store, it will read from the memory.
What about the blue store and the black store?
Blue store, file store. I think
Yes.
Blue Star, File Star, they also read it to the memory first. Some collections they read to the memory first, right?
I'm not sure.
I'm not sure. I am a bit afraid that in case of Bluestar, the call can be actually blocking, because well, get ATTRs can be actually blocking.
Okay.
I would expect that this can actually require some I/O at the site of object store implementation. But well, I don't think this affects our testing. For testing, as it was said before, it will not block on this part.
Yes. The reason I was asking is that it might impact how we design the interfaces. I still think that we need to at least keep it in our minds that we are going to switch over from prototyping to a fully featured Chromis OSD in midterm or long term. Keep this in mind to help us to shape the interface and in the design. I don't really want to just drop the prototype implementation on the floor when we are switching over to a full-blown Chromis OSD.
We need the interface.
Yeah, we need the interface. So ideally, the Chromis OSDs, the interface for find object context would be returning a future. That's the point.
But for the memory stuff, we need to consider return future now.
Yes, I think we are designing around the interface instead of an implementation, because we're going to implement a Chronos D, which is based on Blue Store instead of memory store for the next step. If it involves the very small efforts, we need to design around the interface based on the interface.
So I think we can consider it later because we didn't decided the object store running in POSIX thread or in the Seastar thread.
I don't think we have the bandwidth to port the Blue Store to Seastar. I believe we have discussed this before because the RocksDB assumes the POSIX programming model.
Okay.
And we have done some research on it.
Okay, so then we can record the interface later.
Probably.
So here just called, we can record the interface later for the Blue Star, but the memory star now is running in the Seastar thread.
Yes.
Yeah, so because it's returned quickly, you needn't return a future for the memory
I think
star.
we don't need to, if it involves a minimal change to memory store or to the interface, we need to design around based on the interface instead of assuming that we will be living with the memory store.
But the memory star is
it
different
helps us
usage.
to shape the Chromis OSD.
So,
because our general goal is not to have a prototype. Our goal is to have a fully featured Chromis OSD.
so the Blue Star and the memory star is different usage. One is running in the POSIX thread, one is running in the Seastar thread.
That's the underlying implementation.
Okay, you just want to identify if we use memory style and we return something, and if we use the blue style and we call to the POSIX thread.
Could you say again?
Yeah, I mean, are you mean to implement a interface and to identify if the style is memory style? We just call the memory style function and return the value. If it is called the blue style, if the style is blue style, we have to send the request to the POSIX thread and then return future, right? You mean we need a wrapper for these two kind of style?
So like that. Actually, I think we should, in the current stage, we can just wrap the memory store using the futurized interface. And once the prototype is promising and we want to continue working on it, we need to use the futurized store to wrap all the to adapt to the existing object store.
So memory
and
style
we are
just
targeting
return.
the blue store.
So the memory style, the return is just a Seastar now feature.
Yes.
Right? It's not a real feature. It's just you call the Seastar function, you call the memory style function and return Seastar now.
If you put it that way, it will be realized fulfilled right now instead of fulfilled by the async call. So it doesn't hurt the performance, and then it needs minimum change to existing memory store.
So do you have any question about this IO path?
I think we just need to port it to Seastar and to carve out the minimal path as a Riddle's path. Riddle put in his in the PR.
Oh, so okay, so that's another question I want to discuss. So Riddle's PR is just for example, the existing code is one layer by layer to do the logical check, and the Riddle's code is that to pick up the read to identify if it is a read, and the read path is goes a special path. So is that what we want to do?
So what do you mean by the read path is could you say it again?
I mean, so for some so the existing code will do the there's one layer by layer do the this layer they do some condition check, and another layer they do some condition check, and all the check is done, and it's check the message type is OSD read.
Yes.
Do you mean
They do different checks in the primary log and the PG backends, and also filter some message in the OSD also.
Yeah, so Riddle's PR is that they check for example, do little check and then to check if it is read. If it is read, they will not do the other check and just go a special path for the read. So for other tabs, you can also do the same thing, but there may be some how to say the overlap for these different kind of message overlap between the different special paths. existing code
Yes.
logic is different with Riddle's logic.
Yes,
All
it's
the
different.
in the existing code, all the message type go the same path. They do
Sure.
the
The question is, do we really need to have anything more than just, in other words, is any part of the read path necessary for Crimson that is outside of the fast path, but is essential to work our workload? I mean, at the moment, the PR is just for fast path. The most typical case from the performance standpoint point of view. But it might be also that to do our testing, we'll need to go to some, maybe initially, some rare cases.
So if the PR we want to merge to the master branch, I think you should talk with SageWheel because the original one is the how
It
to
won't
say
be merged.
We
huh?
we won't merge Redux PR. It's just for prototyping.
Exactly.
For
It's just a
showcase
But
how
it modified the existing code logical flaw.
yes.
it's using the existing OSD as a test bed because we don't have the OSD Chromosome OSD driver by then, and we don't have the collection or object non-blocking collection or object by then. It will be how easier to prototype the fast path using the existing OSD. We won't merge it, but we can play around with it to see how it works.
Yeah.
That's
So
the
if
point.
you want to modify the existing code logical flaw, I think we should talk.
We won't
listen to
change the existing code path or read path. It just helps
so
us understand the
so
read path.
So I need to talk with you because the original code is take all the message as the same, and they check each one layer by layer to check the conditions. And the
Yes.
reader PI starts to pick up the read only message, and they go a special branch, special path. That path, if
Yeah.
you can do the same work for other message type, but if you do for the other message type, the other message type go another special paths, then the multiple special paths will have many overlap for the condition check.
I see. It's
I
a
don't think that is
more a design problem. How we
yeah, it is design how to design the
if
logical
we just want to
implementation.
focus on the, for example, to handle the MOSDOP and the read op in it, we can pull all of the stuff in the OSD class. But I think it will be a more extensible design if we can have the PG release the ops in the PG. So I would suggest to have a class, a PG class to host the operations or ops that should be handled at a PG level. And later on, we can design if we need to another class or another set of class which will be handling the I/O path of a PG, because the PG is not only related to I/O, it's also related to a lot of operation which is related to the PG peering and status, which requires more, for example, more the checks you are receiving when you are reading the code, the read path, which involves a lot of shared stuff between the Erasure PG backend and the replica PG end. So in long term, we probably will need to have another layer to abstract the PG backend. But at the current stage, I'd suggest to have an individual PG class in addition to the OSD, which will be serving the, for example, the OSD, the boot up and the shutdown logic of OSD at the OSD level, which will likely to serve the services shared by across the PGs. For example, the OSD map and the metadata collection. What do you think?
I can't follow up with you. So if you want to change the current logic, the design.
We are not changing the current logic. We're starting from scratch, but we can decide if we can adapt the existing logic or existing hierarchical of a class.
So I suggested
but we need to start from something simple and extensible.
Yeah, I suggest we can use the Riddle's PR to do the POC test to do the comparison. But if you want to merge that PR into the existing staff OSD branch, master branch, I mean, it changed the design idea. It's a big
no. We are
decision.
when I don't think we will ever want to merge that Riddle PR as it is into the master. We're more likely
want to merge it.
Say it again, sorry.
So you don't want to merge, right? You just want to use.
I don't think I neither do I think that's the intention of a Riddle.
Yes, maybe some. Let me bring some more context. We started constructing the shortcut for reads mostly because the I/O handling, mostly because the I/O path, the general I/O path of current OSD is so extremely complicated that it was just very hard to dissect all dependencies, all data dependencies we would need to cover in Crimson. That was the idea behind dissecting the really necessary parts of read.
So I think we can use the PR to do the POC performance comparison just for our own use. First,
yes.
Yeah, I agree with that. But if you want to merge, I mean, if you want to merge to the master branch to change the existing code logic, I think it's more work to discussion.
We never wanted to merge it.
Okay, so then no problem. We only need to keep the Ceph OSD and the Crimson OSD the same logic. It's okay. So we can use the shortcut logic.
I think we can use the shortcut logic, but I think we still need to be extensive as we are focusing on the future. But if it involves a lot of work, we can have a minimal change. The way Redux proposing in his PR and port it to Crimson OSD as it is. But I still suggest that we need to have a PG class.
PG class. Currently
yes.
has the currently has the PG class, right, in the existing code.
We're not gonna use the existing code because that will a lot of headache in the future to get the two different design in the same in the same way, in the same hierarchical or.
I don't understand what the.
I don't think we will be reusing the PG class in, for example, in our source OSD, src-OSD.
Why?
I think we need to start from some in the IO path, we need to start from something new.
But we still have the PG concept, right?
That's why I suggest we need to have a replicate the PG layer in the Chromium OSD.
So what's your meaning, the new replication for the PG layer?
I mean, we need to replicate the PG, the concept of PG in Chromium OSD. But we don't want to, for example, just rebuild it or reuse it. Because if we really want to reuse it, we need to be at a source level, be source level compatible with the existing OSD. If that would involve a lot of headaches, I'd rather to just fork it and start from something new, start from scratch.
So can you describe what's the something new?
Something new means that we start from zero.
So for this POC, you want to rewrite the PG layer?
And for the future, the Chromium OSD in future. That's why I'd suggest start from something more extensive instead of put all the stuff in the OSD class.
Okay. So the main work now is how to assign the work to us to cooperate together, because there's it's a workflow, how to divide the work and how to cooperate and merge them
probably
together.
We can go over all the updates of the team members.
Okay, so it's done from me.
Okay. And Jim, how's it going? Sorry to keep you waiting for long.
Because this work I'm doing customer supporting, so no time to message the performance profile.
Okay.
And I also noticed your comments for the ShareRU PR. So I think maybe the next week I will give some result for the performance profile.
Jim, how about that? I will be split redox exchange on existing shared cache to separate the PR. Already you could do it as well, so I can review it. Otherwise, I cannot approve my own PR, even it's original from you. My idea is to split the PR into two pieces. The first one is to just fork the existing shared cache in source Chromium by removing all the unnecessary stuff, because I don't think the weak pointer is necessary if we are focusing on a single-threaded application, right? Because it's used to track the pointers being deleted. If it's an atomic operation, we don't need to track the pointers or objects being deleted, right?
Okay.
So I will be posting a ARU cache based on your change, and we'll adapt it to OSD map cache in OSD driver, and hopefully you guys can take a look at it and review it, and have another PR to which will contain redox change on existing shared ARU cache, so it won't be forgotten.
Okay, I'll reflect this with your comments as soon as possible.
Jim, sorry, I didn't make myself clear. I suggest I will post in a PR to to start from something new, I will post the URL PR and copy you to see if it work, to see if it makes sense. It will be a fork of existing change, removing all the blocks and all the logs and the weak pointer support. And it will customize have a different backend for object context and OSD map, because they have a different requirement. One of them are not the OSD map should be ordered and should be using standard map from standard library, while the object context does not have such kind of requirement. It does not need to be ordered, as pointed out by Redux.
Object context still needs the order by the object name to find.
But the map underneath of the cache does not need to be ordered. It could be implemented by a hash map.
Like
we
the
don't
STD map.
We don't need to walk through the map in an incremental way. For example, we don't need to support the methods like lower bounds. Anyway, I will post you with a PR to see if it works by the end of today.
Okay.
And by the way, Jianpeng, I have a question on the mailing list for your regarding to the custom operations. You replied to the mail on January 9th. I'm posting it in the chat. Probably you can reply me in the mail later on.
Okay, I'll check the mail. Now I can't connect the mailbox.
Sure. Cool. Redux, how's it going?
At the moment, I'm focused mostly on the Messenger v2 stuff.
Okay.
I hope I will be able. Well, we have a deadline to end of this week, and it will be ready. I've just finished the selection of crypto algorithm. We are going to use AES in the GCM block cipher mode. It's extremely performant on Intel CPUs, around 4 gigs per second, both and providing both authenticity, integrity, and encryption.
Are we going to have this feature enabled by default in Nautilus?
I guess that it's for Nautilus. It will be experimental,
Okay.
and the secure in 2 modes will be available. The normal, the default enabled CRC mode, doing no security at all, just checksumming for media transmission. And the second mode is the secure mode with AES GCM.
Okay, so by then we'll have a point-to-point encryption over the wire when we have it enabled.
Exactly. Even more authenticated encryption. So it will address confidentiality, authenticity, and integrity requirements.
I see. So hopefully we can have you in full speed in once the Nautilus is out of door.
I hope so.
Okay, cool. And how about you, Yingxin? I've read your message over the Seastar development mailing list.
Yeah, it's basically saying about we are currently using a dangerous way of the socket,
Yeah.
and they don't make sure that it will work in the future. So it means that if we really need to using the socket and moving the socket, we need to implement in Seastar framework to support some dupe operation of the.
But I recall that AV also suggests an alternative, right?
What do you mean?
I think AV the CTO also suggests an alternative in addition to explain his concern regarding to the usage of. He was proposing an alternative approach for our usage.
I saw this mail, and personally I understood that the alternative is existing only for files, not for the socket at this particular moment in time.
Yeah, they have implementation for the files, but not for the socket.
But the socket is a FD underneath, right? For the POSIX stack.
Yeah, I think he means that there may need some extra implementation if we need to use the same functionality of the files.
Okay, so what do you think? What's your move, Yingxin? Are we going to follow this to be on our own by using the socket on different core, or we are going to implement what AV suggested?
I think it's not our first priority to modify Seastar framework directly, and we can, as it is working properly now, so we can continue to use it and see if the new changes will affect our code. We can do that for now, and in the future, if we have time, we can implement something in Seastar and push back to the Seastar framework.
Okay.
And yeah, I think it is what I think.
Cool.
And I can also try to understand if we can do something in Seastar, because it seems they also welcome this feature to move socket to different cores. So if we can implement, they should be welcome it. But if we don't have time, we can keep the current code working and monitor any changes in Seastar.
Yeah. We can assume that it's safe at the moment. And audit any changes in this area when we pick up more recent change in Seastar.
Yeah, because current unit tests are actually moving the socket. If it breaks, it means we should not upgrade Seastar. And we should prioritize the work in Seastar framework. But another thing is we currently focus on the one-on-one threading model. So it is also not the priority to implement this.
Yes, by one-on-one you mean the one process per one reactor process.
Yeah. So I will keep looking at how to implement, but not take my full time slot on this.
Okay. What about your progress in regarding to the performance of a benchmark of a messenger?
I didn't do it last week. I'm working on to bring up a compatible mode for the sharded messenger. So we can implement the sharded messenger, but also make it work with our current one threaded model. That's what I'm working on. So that means we may not need to change so much in the monitor client, like Redoc proposed to have the foreign dispatcher and some more changes in existing monitor client. We can just, using the compatible mode, we can just change a few lines and make the existing code work in OSD and in monitor client. I think I'm going to this way. So maybe
okay.
Redoc, so maybe your patches, I will need to drop your patches related to foreign dispatcher and
sure. The less change, the better. I'm glad you find. I'm really glad you find the simpler way.
Okay, so
Yixing,
this
is
means
your
that
ready to another round of review?
No, I'm working on it and will push to the SAP GitHub if it is available. I'm just testing it and implement. Yeah, because yesterday I just made some compare errors and tried to find out why, and it is a little distract for me, and finally find it is already solved.
Okay.
Yeah. So from the multi-client perspective, it will not be a sharded service. It will stay as it is. It's just a simple class.
Okay. So let's go back to the action items that we'll be working on. I think the first step is to get the read path ready, and I think Yixing is already fully occupied by the ASIC messenger, because we will have a ready to future complete V2 messenger when Nautilus is released. So I think it's a lot of work in the Crimson messenger side in short term. And
okay.
I think, and regarding to the IO path, I think I will be ready the Seastar so it can read the read and write the collection and object persisted by memory store, and so the Crimson OSD will be able to read the OSD map and write the OSD map in the memory store way, and also will be able to load the metadata persisted by memory store. I think Chenmei, probably, if you are interested, probably you can. You can.
Excuse me,
Please go on.
Kung Fu. So for the memory store, when you read the metadata, you can do it before the reactor startup. So just call the current function, it will be to the memory.
I think we could, but if we have already ported the code in place, we don't need to do it outside of reactor if it doesn't buy us anything.
It doesn't matter. It's the process startup. Process has some initial work to do. At that time, it's reactor that's not necessary. Reactor just for the I/O path work.
I think
that's why it's considering. You can do as what you like, and it's just I think.
I think it's the Seastar way. We do the internalization in the function name start, and it's already implemented. And in start phase, we need to talk to the monitor, which is performing I/O, and it is using the the currency messenger. So it's already there.
Okay.
If you can.
Okay, I see.
You can help us understand what we are missing. I'm glad to investigate it.
Yeah, I will compare the code with the existing OSD initialization and to see if we're missing something.
I would suggest you play around it instead to understand what is missing and what we can leverage from existing code base.
Okay.
And
so go on, please.
Yes, I'm talking about what you would be interested in the I/O path.
So I don't know how to merge the code together. So which?
I think the first step is to. I think first step is to play around the driver, compile and run and start the Vstart.
I mean, cluster. I have to base on your branch, on your code, but you are working and I'm working. How to divide the task? I have to base on your code, right? To do the I/O path.
I think so. We are going to work on the Chromosome.cc, the main.cc and the OSD.cc on the Chromosome directory.
Yeah. So which parts you write or which part I write, and how to merge them together because the code depends on each other.
I think I would suggest you to put my working progress branch, which I posted in the chat.
Okay, so which part are working on? All the code from the beginning of the I/O?
I think you need to figure out how to model the PG and how to shard it. Even we don't shard it, right? How to shard it in a single in a single thread, and how to direct the message to PG layer. Basically, you need to handle the read request in a method exposed by PG.
So for the read, is do multiple condition check. After multiple condition check, they will just call the object store read function from the PG layer.
Yes,
not go to the object store. So
it will go to science store, I think.
What do you mean science store?
Science store is the memory store reimplementation of a memory store in Chromosome.
I see. And so I start from the dispatcher message first dispatch, right?
Yes, but there won't be fast dispatch or MS dispatch. There's just a single MS dispatch in OSD. Probably can. I still suggest you take a look at the
your code.
The OSD class in the branch.
I see. Then I do the following logic, right? From your code.
Yeah, or you can change it as you wish, but we need to keep each other synced, because I'm also actually working on it.
So that I don't know what are you working on it. I am working on the IO path, and what are you working on it?
I'm working on the some facilities, for example, to persist the OSD map and
Okay,
load the PG map.
Okay, I see.
So you are working on PG, and I am working on OSD, or OSD services.
So do you mean I'm working from the primary log PG do request? This is the first PG layer function call for the read operation.
I'm posting the URL in the chat. Probably we can have a discussion offline.
Okay, so
when you
so
feel
can you
appropriate.
write me how to cooperate and from which point I'm working on?
Yeah, we can discuss this offline.
Okay, thank you.
Thank you. So, any questions? Okay, thank you guys, and talk to you guys later. Have a nice evening, have a nice afternoon, and have a nice day.
Thank you,
Thank you.
guys.
See you later. Bye.
Bye.
Later.
See you.